Okay, now you can start this question. Before starting this question, please reset your timer. You have 45 minutes to do this question, and then you can start this question now.
Okay, so today we're going to solve a question called asteroid collision. So we're given an array of asteroids of integers that can be positive or negative. And for each asteroid, which is the number here represents the weight of the asteroid, the absolute value represents its size. So for example, if this -5, then the size is actually 5, and the sign represents its direction. So positive means towards the right, and negative means towards the left. So we want to find out the state of asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are the same size and they're coming in from different directions, both will explode. Two asteroids moving in the same direction will never meet. So this is a pretty classic stat question. As you can see in the examples here,
Yeah.
5 and 10 don't collide because they're both moving right. But -5 will collide with the first, the rightmost number, which is 10, and then they're going to become 5. Or sorry, they're going to become 10 because the bigger one basically eats the smaller one. You can think of it like that. So the approach here is actually pretty simple. And you can see here again, if they're the same size, because -8, the absolute value of -8 is 8. And then they're coming in different directions. So that means they're both basically cancel each other out. And then two asteroids moving in the same direction will never meet. It's important because, for example, here, after these collide, you get 10 and 2, and 10 and 2 will never collide. So because they're all moving in the same direction. So for example, here you can say 2 and 5 collide, resulting in -5 because the -5 actually cancels the 2 out. So it eats away the 2. And then here 10 and -5 come together. And because -5 has eaten 2, we can just ignore it. And -5 is coming in a separate direction, and 10 eats the -5. So we only have 10 left. So as you can see in this problem, the ordering matters a lot. So the most logical way to solve this is to use a stack.
Mm-hmm.
Look through the elements in the array, and then append all of the elements in order, and then check to see if the top of the stack is positive and the current element is negative. If that's the case, that's the only point where we can have collisions, because if we're going like this, if this is the top of the stack, and then this is current element we are seeing in the input, there's no collision because they're both going away from each other.
Okay. Yeah, just go in the same
So
direction.
for example, if you have -8 and 8, there's no collision because they're going away from each other instead of towards each other. So this is the only case where there is a collision, where the top of the stack, for example, in this case, the stack would be 10, there would be 5, and then 10. And then we would be seeing -5 as our current element. And then we would pop off the stack. So then we can essentially compare these two and say 10 eats -5. So just don't add -5 to the stack. And at the end, you notice there's only one element in the stack, so the element is just going to be the only asteroid left. Or in the case where there's, no more collisions to happen. So basically, anything that could have possibly collided has already been collided, meaning the stack is empty. Then we can just return the state of the stack. Or if it's not empty and we reach the end, then we can also just return the state of the stack.
Mm-hmm.
So let's run through some more examples. So here, for example, 10 to -5. First of all, our stack is like this, and then our stack becomes 10, 2. And then now we're seeing -5, and there's a potential for a collision. So pop 2 off the stack. So 2. And now we know that -5 plus 2 is less than 0. So -5 eats 2.
Oh, it's 2. Okay.
So don't add -5 to the stack. So yeah, if I'm doing this correctly, yeah, -2 and 5. And then because we don't have anything off the stack and we have all of our collisions, because this guy eats this guy.
Because 5 is greater
And if
than
you
2.
see right here, it says if 2 asteroids meets, the smaller one will explode. The smaller one will explode. We don't have to do anything to the stack because -5 was never added to the stack. We just don't add -5 because, or we just pop 2 off the stack without adding -5 because -5 is the one that ate 2. So if this guy cancels this guy out, then we're going to actually pop from the stack. If this guy eats this guy, then we're just going to leave whatever's on the stack. So for example, if we had 10 to 5, then the final result would be 10 to 5 because there is no possibility for any kind of a collision. So it's a bit confusing. It makes hopefully the examples cleared up a little bit.
Yeah, I think I understand. You can start code up.
But yeah. So again, as we said, we're going to loop through our array. And we're going to append everything as long as there's nothing in the stack. So so while stack, and as we said here, stack -1 is bigger than 0 and a is less than 0, then we have a collision. So we can say collision difference equals to stack -1 plus a. That's going to be the -5 and the 2, for example. If collision difference is less than 0, then that affects whatever's on the stack, so we can stack.pop, right? If the collision difference is bigger than 0, then the guy was eaten, so we don't even have to add it to the stack. One second, let me see. If collision difference is less than 0, stack.pop. Okay. So we can just set a equal to 0 because 0 has no weight. So that's the equivalent of not adding this guy to the stack if this guy was bigger, if 2 was bigger than -5. In the case where the collision difference is equal to 0, as the instructions state, then we're going to do both of these things. We're going to pop off the stack and we're going to set our current asteroid to 0 because basically both explode.
Yep.
This is not going to be true in the first turn because the stack is empty, so we have to add to the stack. We only add to the stack if the number is positive or not equal to 0 in this case. Because if we have a negative, for example, if we added a negative first and then we have a positive, that's going in the opposite direction away from each other, so that really doesn't matter. And then in the end, we're just going to return stack.pop. And that should be the state of our asteroids after all the collisions. So let's run this.
Oh, okay. 10 is not valid.
Oh, return our stack, not stack.pop, because it could have more than one value, I think. Yep. It's just a stack.
Okay. So what's the time complexity?
Time complexity is O of n because we're only looping through the input array once.
Okay.
So if the input array is size of n, then it's O of n.
Okay.
And the space complexity is, I believe it's O of 1 because we're using a stack here.
Yeah, you are using a
And we're popping and appending, which is very efficient.
So why is
Actually no. I think it's O of n because
yeah.
for
Correct.
a deck, a doubly ended queue would be O of 1, but a stack is O of n.
Yeah. Correct. So thank you for telling me this one, and I will restart recording.